Good morning, students. Chapter 6, Work, Energy and Power. Yes, we will see one question which is based on law of conservation of mechanical energy. Here it is, example 6.7. A bob of mass m is suspended by a light string of length L. It is imparted a horizontal velocity v0 at lowest point A, such that it completes a semicircular trajectory in the vertical plane, with the string becoming slack only on reaching the topmost point C. Obtain an expression for V0, speed at point B and C, and ratio of kinetic energies Kb and Kc. See, you are given figure like this. It is a string of length L and one bob of mass m is connected at its end. A bob of mass m is suspended by a light string of length L. Okay. It is imparted a horizontal velocity v0. It is imparted a horizontal velocity v0. Okay, such that it completes a semicircular trajectory in the vertical plane. It performs semicircular trajectory. It performs semicircular trajectory. Okay, yes. See, it performs semicircular trajectory like this. Like this. Okay. Yes, it is given point B and it is given point C. It is given point C. Clear about this? Okay? Yes, you are given figure. Don't worry about this. It is point A. It is point A. So see again, a bob of mass m is suspended by a light string of length L. It is imparted a horizontal velocity v0 at lowest point A, such that it completes a semicircular trajectory in vertical plane, with the string becoming slack only on reaching the topmost point C. Here it will become slack. String will become slack. Okay. So yes, you have to find expression for V0, speed at point B and C, and ratio of kinetic energies Kb and Kc. Okay. See here, in this whole process, okay, when this bob is going from A to B, then B to C, okay, total energy, that is total mechanical energy, it remains constant. Total mechanical energy means kinetic energy plus potential energy. For potential energy, we have to assume some reference surface. I am taking reference surface passing from A. Let reference surface is passing from point A. So yes, at point A potential energy will be 0. Yes or no? At point A, I am taking this surface as reference. So yes, what is height of point A from this point? It is 0. So potential energy will be 0. Clear about this? Clear about this? Okay. Now, at this point, when bob is at this point, here I will find numbers of forces. See, at point A, that is lowest point. That is lowest point. At point A, lowest point. Okay. See, mg, that is always acting in vertically downward direction. Yes or no? As this bob is connected with string, tension is produced in this string. Tension is produced in this string. At this point, what is the speed of bob? It is v0. And yes, see, observe, this bob is performing circular motion. This bob is performing circular motion. Yes or no? So for circular motion, what is required? Centripetal force. For circular motion, what is required? Centripetal force. So here at point A, required centripetal force is provided by resultant of these two forces. See how to write. Okay. At point A, required centripetal force. Centripetal force mv square upon r. M mass, v speed, r that is radius. Here how to write centripetal force? See, m mass of bob. At point A, what is speed? v0 square upon what is radius of this circular path? It is L, that is length of string. So yes, this mv0 square upon L is equal to, provided by resultant of these two forces, Two forces are acting, one is T and another is mg. One is T and another is mg. Yes, here tension is greater than mg. So yes, here it is T minus mg. Because they both are in opposite direction. They both are in opposite direction. So I am taking T positive and mg negative. Clear about this? Clear about this? Any doubt? Here, at point A, as there are two forces on bob, so required centripetal force is provided by the difference. Clear? Now, at point A, yes, here it is, at point A, I will find total mechanical energy. Mechanical energy. See how to find mechanical energy. Mechanical energy, EA is equal to KA plus UA. Ka means kinetic energy at point A, UA means potential energy at point A. See, kinetic energy, half, mass of bob is m. What is speed at point A? It is V0 square. Plus UA, yes, mg. Here at point A, we are taking potential energy 0. We are taking potential energy 0 because reference axis, reference line, reference surface is passing from point A. Okay, so EA is equal to, it is half m V0 square. EA is equal to, it is half m V0 square. Equation number 1. Clear about this? Now, this bob is moving, string is under tension, Now when it reaches to point C, here it is given C, such that it completes a semicircular trajectory in vertical plane with the string becoming slack only on reaching the topmost point. So now at point C, as at point C, the string becomes slack. Okay, string becomes slack. So it means at this point tension is 0. At this point tension is 0 because string becoming slack means tension in string is 0. Tension in string is 0. So yes, when bob is here, numbers of forces acting, it is only mg. So if at this point speed of bob is Vc, then here required centripetal force. How to find? Let speed at point C is Vc. So therefore required centripetal force. Required centripetal force. See how to write required centripetal force. M Vc square upon L. Mass of bob is m. At point C, what is speed? Vc. So Vc square divided by radius is equal to only mg forces acting. So it is equation number 2. It is equation this. M Vc square upon L is equal to mg. Any doubt? So see, this m cut. So what is Vc square? Vc square is equal to, it is GL. Vc square is equal to GL. So Vc is equal to, it is under root GL. Vc is equal to, it is under root GL. Any doubt? Okay. Now we have to find what is VO. So how to find VO? I will find mechanical energy at point C. Mechanical energy at point C. EC is equal to KC plus UC. Kinetic energy at point C plus potential energy at point C. Kinetic energy, its equation, half m Vc square plus UC means potential energy. Potential energy, its equation is mgh. H, that is height from reference surface. It is reference surface. From this reference surface, what is height of C? This length is L. Then obviously this length is also L. So yes, what is height of point C from this reference surface? It is 2L. Yes, it is 2L. Clear about this? Yes, it is 2L. So yes, EC is equal to, it is half m Vc square plus mg into 2L. EC is equal to, see here it is, Vc square is equal to GL. Yes, Vc square is equal to GL. So it is half m. Vc square is replaced by GL. Okay, plus it is 2 mgl. Now if I simplify this, then EC is equal to mgl plus 2 into 2, it is 4 mgl divided by it is 2. So EC is equal to 5 mgl divided by 2. It is equation number 2. Now what is law of conservation of mechanical energy? Okay, mechanical energy remains constant. So yes, if I find mechanical energy at point A, if I find mechanical energy at point C, then it will be same. So according to law of conservation of energy, according to law of conservation of energy, EA is equal to EC. EA is equal to EC. Clear about this? What is EA? Here it is. EA is equal to half mv0 square. Half mv0 square is equal to, what is EC? It is 5 by 2 mgl. So see, m cut, 2 cut, 2 cut. So v0 square is equal to 5gl. So v0 is equal to under root 5gl. V0 is equal to under root 5gl. V0 is equal to under root 5gl. Clear about this? Clear about this? So yes, at this point, at lowest point, speed of work is under root 5gl. Under root 5gl. Clear? You have to also find speeds at point B and C. Yes, at point C we have speed. Now what is speed at point B? What is speed at point B? So see, at point B, we will find total energy. See, at point B, mechanical energy, EB is equal to, yes, it is KB plus UB, kinetic energy plus potential energy. If I am assuming at this point speed is VB, then I can write EB is equal to, it is half m VB square. UB, yes, UB, here it is. See, this point B is at height L from reference surface. Yes or no? So what is equation of potential energy? mgl. It is mgl. Clear about this? Clear about this? Okay. Okay, now how to find? See, here it is. According to law of conservation of energy. According to law of conservation of energy. Yes, if I find total energy, mechanical energy at any point, at point A, at point B, at point C, they are same. So here I can write EB is equal to EC. What is EB? It is half m VB square plus mgl. What is EC? Here it is EC. It is 5 by 2 mgl. So yes, half m VB square is equal to 5 by 2 mgl minus mgl. So half m VB square is equal to 3 by 2 mgl. If you simplify this, you will get 3 by 2 mgl. M cut, 2 cut. So VB square is equal to 3gl. VB square is equal to 3gl, and therefore VB is equal to under root 3gl. VB is equal to under root 3gl. Clear about this? So yes, first question, what is V0? Then what is VC and VB? And now last question. Ratio of kinetic energies KB and KC. Yes, it is simple. KB upon KC. KB means half m VB square upon half m VC square. Half m cut. What is VB square? Here it is 3gl. What is VC square? VC square. Yes, here it is under VC square is equal to, it is GL. So GL cut. So your answer is 3. Your answer is 3. Clear about this? So yes, it is one most IMP question from chapter number 6. It is one most IMP question in chapter number 6 for 4 marks. Clear about this? So yes, You have to solve this question. Yes, it is easy question. Okay, one last question is there. Okay, if we release the string here, what happens with its motion? Then yes, this bob will perform a complete circular motion like this. Clear about this? So yes, it is one important question from chapter number 6.